Hey everyone, let's take a look at capacitors in AC circuits. We just finished talking about inductors in AC circuits. On the left here, we see a capacitor in an AC circuit. As the capacitor charges, the voltage on the capacitor increases and the current decreases. So what I'm saying here is just like with the inductor, the current and the voltage are not in phase. We see this in this graph here. So at first, there's a whole bunch of current in the circuit because the capacitor hasn't charged yet. We know that when the capacitor is fully charged, if you remember from the DC circuits, when it was fully charged, then there was no current in the circuit. So if there's a lot of current, that means that the capacitor has not charged yet, and so there's no voltage across the capacitor. As the capacitor starts to charge up, you can see the current is decreasing and the voltage is increasing. And then what happens is the current is going to change direction, so then the capacitor is going to start to discharge. And the cycle continues. What's important, just like with the inductor, is that the current and voltage are not in phase. In this case, the current leads the voltage. The current has its maximum before the voltage does. So we saw that with the inductor that the voltage led the current. I do have a mnemonic to remember this. I learned it in school a long time ago. It's called Eli, and actually we use this Eli, the Iceman. If you remember this, then you will remember the relationship between current and voltage for inductors and capacitors. So L is for the inductor. The EMF or the voltage is before the current. That means that the voltage leads the current because the voltage is before the current for the inductor. For the capacitor, which is the C here, the I comes before the voltage. That means that the current leads the voltage. So that's just a way to remember that. But again, the important thing is that they're not in phase. Just like with the inductor, a capacitor impedes the flow of current in a circuit, and we call this the reactance of the capacitor because it has an effective resistance in the circuit. So the expression for the capacitive reactance, which is this X sub C, is 1 over 2 pi Fc. So it's the opposite as the inductor. It has the opposite effect. As you increase the frequency, the reactance actually decreases. And this makes sense because as you increase the frequency, then it's really hard for the capacitor to charge up because it keeps charging and discharging and charging and discharging. And so it doesn't oppose the current as much. It has a low reactance with a high frequency. Just like with the inductive reactance, reactance has units of ohms. Just think of it like a resistance in the circuit. The good thing again is that you can use Ohm's law. If you're trying to find the voltage across the capacitor in your AC circuit, instead of multiplying I times R, you multiply I times the capacitive reactance. Let's do a final your turn for this question. For this section, if the value of the capacitance is doubled, then what happens to the current? So you've got to think about it and figure that, well, the current is affected by the reactance, right? Because you can think of reactance as a resistance. So if you use Ohm's law, you know that the voltage across the capacitor divided by not the resistance, the reactance, the capacitive reactance, gives you the current in the circuit. This is from using Ohm's law. So how does changing the value of the capacitance, how does that affect the reactance? Once you know how it affects the reactance, then you'll see how it affects the current. So it's a two-step process. First step is figuring out that the reactance is 1 over 2 pi Fc. So if we double C, you can see C is in the denominator, right? If you double it, if you have 1 over 2 pi f times 2c, then you now have half of what we had before. So doubling the capacitance cuts the reactance in half. The reactance is half. Okay, so back to here, if we now have 1/2 of the reactance that we had before, then you know that when you divide by half, it's like multiplying by the reciprocal. You're going to have twice the current if you have half of the reactance. So the current is going to be doubled. That's all for this section. The next section, we'll look at resistors in our AC circuits.